Hello, this is Clint Halstead, and this is an Adjunct Training presentation I put together. So I'm going to go over several different things that can make you successful as an adjunct, and the first is SkyDrive. So in order to share files, collaborate, make sure you have backup data, access your data anywhere from iPhone, iPad, Android, PC, laptop, projector. The projector PC in the classrooms is what I mean by projector PC, and the main reason for this is because there's limited amount of space on those computers, usually in the thaw space area, and everyone has access to that data, even students if they went up to the computer. So SkyDrive will allow you to access your data that's on your computer at home or on your laptop from the projector PC, where you can present your PowerPoints without having to have a thumb drive or something like that. You can also download to your PC and you have web access. So let me show you SkyDrive really quick. SkyDrive. How do you get SkyDrive? Well, you just type SkyDrive, and then this is a Google search, and it says Windows SkyDrive download. So click that, get SkyDrive, click that, and then it'll download it to your computer. Or the way you're probably going to get it is in an email from me. I'll actually get your email address, and I will. What I do to do that is I go to my SkyDrive account. If you'll see here, then I have a SkyDrive link when you install it. And what I do to give you SkyDrive is I go to courses, I go to the folder that I want to share with you, I right click and I say share, and then I'll put your email in there, and it'll send you an email that says please download SkyDrive if someone wants to share a file with you. And a lot of people do not want to download the actual program, but you should, because if you do, it gives you this link and makes it part of your Windows Explorer, so you don't have to go to the internet each time, and you don't have to log on each time. It just simply becomes a folder on your computer. So you can access your files just like you would normally on a computer. You don't have to go to the internet or do anything special. It just automatically populates. The check mark means that it has been populated, and if you create a new Microsoft Word document, for example, you can see that you get the little arrows, which mean it has not synced yet. It's going to synchronize. It's going to upload that to the cloud. Then once it gets done, then it gives you a little check mark. Once it synchronizes to the cloud, you can access that data from anywhere. For example, if I go to, just type SkyDrive, you can do this from a projector PC at Mitchell, where you're locked out of most everything, but you can click on SkyDrive. It says access files from anywhere. You'll have to log on, but once you log on, you can see here that I have my documents. I have Mitchell. If I click there, then I have all my folders. If you don't like this view of it, then you can change the view to more of a regular Windows Explorer type view, where you have folders, and you can sort by name. You can show or hide the pane. So now I can go to my courses. I can go to DC circuit analysis. I can go to my slides, and then I can go to my PowerPoint slides. I click that, and then it opens up a PowerPoint web app, so you don't really even have to have PowerPoint on the computer either. That's another advantage. So now, without even having PowerPoint, I'm able to go ahead and start doing my slides. Another way you can do that, if you don't want to wait for that app to load, you could just click on it. Oh, no, sorry. you could right click the file and say download. Then it'll download it to your PC, to the thaw space or whatever, and then you can just open it, once it downloads, then you can just click it and open it, and then you would have the ability to do whatever you wanted to with it, make changes to it, whatever. Alright, so that is the SkyDrive tutorial. Now let's look at an example. Okay, so if you look, one of the examples is ELC 138 DC circuits. We have labs, lectures, lesson plans, master lesson plan, simulation, solution slides, and solutions manual. That's all part of what I create and make available to the adjuncts. So here, if you double click, this is just my Windows Explorer, and this is all synchronized and shared with you. So books, this is where the books are at that I have to submit to the bookstore. The main text, you open this document, it tells you the book, the ISBN number, all the extra supplies that they have to have. They're required to have National Instruments software, they're required to have a thumb drive. Tells them, the bookstore, where to order the software from, everything the bookstore knows you can know right here. And then the lab manual, all the information for the lab manual. CAD tutorials, I put in there. Labs, all the labs by class period, or the class number doesn't really mean anything, doesn't really mean a day or anything, it just means that's the right sequence. So the lesson plan determines, lesson plan template determines what order we go in, or what day we actually have that lab on. But usually I have in here different files. Sometimes they're PowerPoints, sometimes they're PDFs. A lesson plan many times will be, it tells you everything you want to do, the name of the lab, objective, what's the objective, how much time you're spending in the lab doing quizzes, introducing the concept, lecturing. Usually for a lab we want to do mostly an activity. Have students do a power supply and DMM hands-on activity. And then you would have an associated, usually Word document along with this. Over here it tells you the materials needed, any announcements, they need to purchase a multimeter for home use. You can change this, you can do whatever you want with it. Preparation for next class, what do they need to do for the next class? And then you have pass out, take up, grade. Do you want to grade something that they had to do this for this period? Or do you want to prepare for next, if they want to prepare for the next class? And then next time, what is their lab? Just let them know. And okay, so that's labs. You have lectures, or the same basic format. A lot of times you'll have a lesson plan and a PowerPoint. So the lesson plan is nice to fill out before class, just so they can say, okay, it helps the instructor to think about what they're going to do and prepare. You know, 5 minutes for grading your quiz and giving back the answers, giving back homework solutions, introducing the concept. Many times it's better not to just start off saying, okay, here's the topic, but to introduce it in a way that's interesting. Like, have you ever thought about where electricity comes from? Ben Franklin was the first person to play with electricity. Then you start talking about electricity, or you do some little video, but something to spark their interest, maybe a practical application, something to get them interested. A lot of times you can ask questions to get them engaged at the beginning, and then you do your lecture. And then activities, if there's going to be activities, let them allow 10 minutes, it says here, for students to experiment with electricity, and then evaluate them if they participate in the class. If you want to have some sort of daily assessment, it's your opinion how you want to run your class. Many times you may want to walk around and assess students as they're doing activity at the end of the lecture to see, did they get it? Don't assume that they got it just because you said it, because usually if you say it, they didn't get it 80% of the time. You have to reinforce it and let them do it on their own, let them say it, repeat it back to you. This has the same things we already went over, so I'm not going to go over this anymore. But then this would also have the PowerPoints to go with that lesson plan, and then you could just go through the lesson. This has videos. It's good to have videos, or you could say, you could put these on Moodle and say, we don't have time to watch this video, but you can watch this video at home. Okay. Dosuri Desktop, the next topic. A cool application is Dosuri Desktop. You can Google that, and I'll do that right now so that you can see what pops up. So Dosuri Desktop, interactive whiteboard for iPad. You put a copy on your PC, you put a copy on your iPad, and you can display anything on your screen on your iPad, and you can draw and save it and record it, and it's free. So that's pretty cool. I don't know if you can do it through the school computers yet, but you can do it if you have a laptop. If you want to borrow a laptop, if you're an adjunct, then I have a computer that I can let you borrow, and I'm going to work with IT on that. But I do have an extra laptop that I may have to log into, but eventually I'm going to try to create an account for the adjuncts. Google Plus is free video capture software. It's web-based, free, run from projector PCs, don't have to load any software, don't have to have admin privileges. Good for enhancing your class, prevent students from retaking or re-asking the same question, so you can record your lectures with the cameras that we have in the classroom, and then post it on the internet just so they can re-watch it, or if someone missed a class. So how does that work? Go to Google, sign into Google, create an account on Google, whatever. You have to have an account. You click the little plus sign, it has your name here. Takes you to Google Plus. Then you click on the right side, Hangouts. Actually, you don't really have to do that. Just left click over here on the home thing. It says Hangouts on Air. And when you do that, you have to say Start Hangout on Air. It opens a new window. And then with this window, okay, I have to install the plugin, which I thought I already had, but maybe I've never run it on this PC. Didn't really think about that. So let's give it, normally you don't have to do this, but only once. Sorry about that. Once that loads, then you're going to get this screen, and you can see my video camera is working. You say join. Type in a name. Add the names of the people you want to join. You don't have to have any people on here. Start Hangout on Air. And now you can see me. And I don't want to see my space, so I'm going to do a screen share. So, start screen share. So you can see my other screen. I have two screens. So now you can see my other screen over here. Yay, I'm moving my mouse around. I click on multi-sim. I could open it if I wanted. So that's cool. And you can actually broadcast this, and if you do broadcast it, then it will, what it does is actually uploads it. As you're recording it, it's uploading it to YouTube in real time, so that you don't have to go upload it to YouTube later, which is just a big hassle. And then, you know, all your files will be on YouTube, and you can make that private, or you can make it public. So YouTube is not just all public. Some of it can be private. You get to decide how you want to do that. But I make everything public. Every single class, that's your right as an instructor to make it public, share it with the world. I have people from all over the world, weirdest countries in the world, thousands of hits a month from my microprocessor class. So it's kind of a neat thing to do. It can help establish you as a teacher. You can advertise Mitchell or not. It just depends on what you want to do. I usually make this generic. I don't mention anything about Mitchell. I don't mention anything about anything specific. I just make it as generic as possible. I don't talk about assignments. I really just talk about the lecture and the content of the material and getting the point across. So I'm going to close this thing down. I'm going to exit. Say end broadcast. So I actually wasn't broadcasting at that point, but okay. So that is Google Plus. Google Plus. Now WebAdvisor is something in the Mitchell website. It is here at the main Mitchell website, and that's the link. Okay, so WebAdvisor. This is used to see student rosters, see your paycheck stubs, used to create educational plans. The adjuncts don't have to do this, but I wanted you to know anyway. Used to see all sections of all classes that Mitchell offers, registration dates, used for grading, which is required, and attendance tracking, which is required. You have to have an account, and you should have an account. If you don't, we need to get you an account. MCC Directory at the top of the page, and Mitchell, and I'll show you that. Directory is right there. And can find anyone at Mitchell by name or department. So if you don't know the name of something, but you know that you want admissions and records, then you can click admissions and records, and you can just pick one of these emails and call whatever number you can until you get someone from admissions. Bookstore, accounting, math department, whatever you want. Very helpful. Okay. Moodle. Of course, it's used to deliver online content. It's on the right side of the page with this link on the Moodle main website, on the Mitchell main website. And basically, it's a web page that creates a web page. Make an appointment with Gail Elmore for one-on-one training. It's required to do this. And here's her phone number, and here's her location. This needs to be done before the semester starts. Link is located on the main Mitchell website. We already talked about that. The Events tab on the main Mitchell website. This should be called Calendar, but it's not. You can click Events. It shows all the calendar. You can go to future months. It tells you when the drop add date is. You have to hit go in order to make it work. But you can see everything. Drop add, when the class starts, when the semester starts, when it ends, finals, exams, whatever, special events, most everything. Okay, email, of course, is on the main site. It's Outlook. You use it to do email, scheduling, address book, and web-based. I would suggest using the scheduling feature, and that's something that not a lot of people do, but you have the ability to look at people's schedule and put all your things on the schedule so everyone else can see your schedule. It's a very good thing to do. Teaching tips. Okay, so the first day of class sets the mood for your entire semester. Students, I'm going to read this, I know verbatim, because you're not supposed to do, I know you're not supposed to do that, but I'm going to do it anyway. Because I wrote all this exactly the way I wanted to say it, and I think this is going to be good to go over really quickly. First day of class sets the mood for your entire semester. Your students do not know what you're thinking or what you expect, so you must tell them. And you need to do this on day one, because otherwise, I don't know, there's something special about day one. You have to set the precedent for the rest of the class. They have to know who you are, what you expect. It's like the first impression. I don't know, you can never change your first impression. Use the syllabus for this. Make sure you have everything on there that you want. I will give you a template that I use, and you can change it if you want. Don't come across as a pushover on day one. You would rather come off strong and mean, and then you can lighten up later, but don't come over as a pushover. Don't come across like, oh, you can turn your homework in anytime you want, because they will take advantage of you and you will regret it. If something's late, reduce the credit. Someone says, can I turn this in tomorrow? Sure, reduce credit. I was sick, reduced credit. You don't have to reduce a lot, depends on the situation. Give yourself leeway in the syllabus to make your own judgment. I wouldn't stick yourself to a specific rule, because you may have someone come in and said their mother died, or they had jury duty, or they had something where you went, well, I really don't want to punish them for that, but you can give them a small reduction. You don't want to lock yourself down. You want to be fair to everyone, but different situations, just put in the syllabus that you're going to reduce credit on a case-by-case basis, and it's your call. Just let them know that it's your call. You're going to make the decision. You don't have to lock yourself into a particular decision on day one, but you can let them know that you are most of the time going to reduce their credit, and let them know what you expect that to be, and then you can always change it if you want. You can be more gracious if you want. Give yourself a leeway. Don't lock yourself down on number, points, quizzes. Give a range if you want. Like if you say you're going to have 10 quizzes and you're not able to give 10 quizzes, then someone could come back and say, well, I would have got a better grade if I would have had more quizzes. But, well, give yourself some leeway so that if you're not able to give that many quizzes, then you can get out of that if there's a situation where a student complains about his grade. Grading for the core program classes, DC circuits, AC circuits, digital microprocessors, PLCs, A, B, C, or F. A D is not acceptable for a core class. Why do you want someone that gets a D, which is unacceptable, to go on and take the next higher level class? So mostly it's for classes that have a higher level. So we have PLCs, we have advanced PLCs. We don't want someone in advanced PLCs who can't even get basic PLCs. We don't want someone in AC circuits who can't get DC circuits. It just is common sense. So don't give anyone a D. So on your syllabus, all you have to do is say 90 is above is A, 80 above is B, 70 above is C, anything below 70, F. And let them know that on day one. Core classes is DC circuits, I already talked about this, microprocessors, PLCs. I would suggest that you not give, please no Ds in these, these classes. Make sure a C student meets the department's minimum level of standards for someone going to an interview in the industry. We do not want to give a degree to anyone that will embarrass us on a job interview. That's a pretty basic level of understanding that we don't want to discredit our department or the school because we passed someone that really don't know what they're doing. You just want to get rid of them. You're sick of them. You don't want to do that. You can give them an F or give them a D if it's the right class, but don't let them get past the program if they don't know the basics. And that's why we have the minimum standards. That's why we have the final assessment. If someone cannot pass the final assessment with 80 or better, they should not be passing their courses. And I'll give you a copy of the final assessment so you can have that. Assignment tips: assign homework and reading assignments. Today's students especially. I would recommend assigning homework and reading assignments to all students really. But especially day students, because if someone has a job at night, it's going to be harder. But you can still assign it. It doesn't mean you have to make it count a lot of points. How extensive depends on upon you and what you know the student workload is. If you have all night students and you know they're working 12-hour shifts, you can give them assignments, and if they don't do them, you can let them know that if they don't do them, they're still going to have a good chance in the class. Or if you don't think they will, it depends on the student. Some students are going to need help outside of class. A lot of the things that we do, they're going to have to get their own hands on, and you can let them do that during class. So you can give them an assignment, let them do that assignment in class if you want. And also, I would not count homework a lot of points, maybe 5% of their grade, so that you're encouraging good students to do it. Students that are C students, they're probably not going to do it. That's okay. They're still going to be able to pass the class if they don't do it. But you want to always think about your best students and your worst students. Not really your worst students, but your C students. Think about your C students. Your worst students, there's nothing really you can do. They're not going to do anything. They're not going to learn anything. But your C students, they just want sometimes just to get by. That's all they want. They want a C. A lot of times the C students, they want a C. That's all they want. As soon as they have a C, they don't work any harder. So give them a little bit more incentive to work. Give the A students incentive to work too. The A students are going to, if you teach at the C level only, the A students are going to be bored. And that's a shame, because the A students are the ones that everyone wants to hire, not the C student. So design your class mostly for the A students, but consider that the C students, if they meet the minimum standard, they still need to pass. Plan by the week, not the day. Don't get caught up on what's done today. Plan for the whole week. Because if you get behind on day 1, you can make it up on day 2. Vice versa. You can put stuff on the internet. Many students may not be able to complete an assignment during the week, but it can be complete on the weekend and turn in on the Monday. So if you got night students who are working long shifts, you know they're not going to be able to do their assignments at all. Make it do. Give them an entire week to do it, and then they can work on it on the weekend. If they really care about their education, they'll spend a little bit of their free time on the weekend doing it. This is not their whole lives. It's just a small period in their life where they're trying to get an education so they can better themselves. So they should be willing to do that. Assign 1 to 4 homework problems per class. May do in class, but let them try on their own. I'll also say this: never give an assignment that you don't give the solutions to. You need to either make sure that you give them the solutions the next day or the next week or whenever it's due, or pass out or make available on the internet the solutions, preferably not the solutions that are provided to you from the textbook, and not more than what is on that they've been assigned. Don't give them the entire instructor solution. That's a big no-no. What you can do, the best thing to do, is to work the solutions out yourself and show them the way you want them to do it, handwriting, whether you want them to draw a diagram, the way you expect them to do it. You draw it out, and then you make copies and you give to them so that they can do it. Let them try on their own. Try to wean them off of you slowly if you have students that want your help all the time. Try to wean them off of you so that they work independently. Assign reading assignments for home. Again, if working day jobs, allow them to complete on a weekly basis so they can do it on the weekend. Don't overload working students too much, but don't assign too little. Don't assign nothing. Find the right balance. Consider assigning homework and reading outside class, but make the homework grade less than 50%. I already talked about that. This will motivate the A students. We talked about that. Don't have to grade. You don't have to grade the homework. Just check it off. When you do your roster each morning, have them walk up, say, when I call your name, come up and show me your homework. If they don't have it, they don't have it. It's not going to affect their grade that much. The A students are going to be happy. They're going to be excited to show you. They're going to say, hey, look what I've done. Look what I did. And that's exactly what you're wanting. You want to reward them for doing their homework. You want to give them a reason, incentive, even if it's a small incentive. If you want to pass out a candy bar to the person who did their homework the best, or anything, the simplest thing to do is just look at it. Give them a couple points every day in your grade book. They love it. Okay? It's an easy, simple way to motivate someone. It's all about motivation. Grading tips. Grading is very important in electronics engineering technology. It determines how we are viewed by the public, which includes surrounding industries. A C student should make 80% or better on the program final assessment, which is our minimum level standard for the program. In layman's terms, this is our okay, don't embarrass us, or don't give the college a bad name type of standard. See myself, Clint Halstead, for the minimum standard or the final assessment. Grading tips again. A C student will many times understand the basics and the first or initial level of understanding of a topic. A qualitative, or qualitative means conceptual level of understanding, not numbers based, but be able to define terms, pick the right answer out of a list. Now, it could be minimum level of quantitative or numbers, very initial level of quantitative. I should have put that in here. Initial level be able to define terms, pick the right answer out of a list, fill in the blank. This is your standard test. Fill in the blank, multiple choice type stuff. Write the most basic equations, be able to draw the basic diagrams. Test basic circuits in the lab. Be able to analyze a basic circuit with 2 to 3 elements. Very beginning level. This is our minimum level of standard. They have to at least know the fundamentals to get out. They don't have to know advanced things to be a C student. A B student, you're going to have to align your grading. You need to, the test most likely will come from me, and so I'm going to work on aligning the test, which is a summative assessment, to make sure that we meet these minimum level. A B student should be at an intermediate level of understanding the program, a qualitative and somewhat quantitative level of understanding, be able to solve beyond the initial or basic level of a circuit, be able to not only to pick the correct term but to explain it in his own words, be able to build beyond a basic circuit, be able to test a circuit for proper operation, be able to analyze a circuit, not design necessarily a circuit with 4 to 6 elements. So I would not really expect a B student to be that great of a designer, but maybe they could analyze this intermediate circuit. Most of these things I'm talking about, I'm referring to analog, because analog is the most difficult, but it could also equally apply to a digital type circuit as well, and PLCs or anything for that matter. An A student should be at an advanced level of understanding the program, a qualitative and extensive quantitative level of understanding. That means math and conceptual. Be able to solve complicated circuits, 7 to 10 elements, in series, parallel. Be able to do, of course, the advanced node voltage method and superposition, things like that. But to compare and contrast different terms and applications, be able to build advanced circuits, be able to not only test but troubleshoot circuits. Troubleshooting circuits is one of the highest levels of understanding. You have to not only know how to analyze and design, but troubleshoot is almost like a reverse engineering and then problem solving. It's very, very difficult. This is the highest level of understanding in our program. Or to specify a new circuit or redesign a circuit and change it or improve it. To be innovative. Highest level of understanding. Be able to design a circuit with 7 to 10 elements. The lecture tips. Don't go over everything in the book. Just do a quick overview. Let the students know that they should take notes, especially when circuit diagrams are concerned. They need to practice because many times they cannot draw schematics very well. Their first schematics look like chicken scratch, so you need to be able to tell them to practice. You can actually, so that they can practice during class. Hopefully they will not be afraid to waste paper. Let students know if they want an A or B, they need to read. If they want a C, they can do the minimum. Let them know your expectations. If you expect them to read, then you need to let them know that. If you're going to tell them everything they need to know, I don't see how you could do it, but I believe they could probably get a C if they pay attention and take notes. If they don't read their book, maybe. But I would think, I think a C student would be doing homework some of the times, not all of the times. They would be reading some of the time, not all the time. The D and F students, or the F students, are going to not do anything outside of class. They may pay attention, may not. That's how I would describe that. Lecture tips. Books have far too much material to cover in most cases. Books are designed to pick and choose sections. If you go straight through a book in sequence, you will get one of two things. You're only going to get through half the material because there's too much information in the book, there's too much material, because it's not designed to go straight through. Or, if you do get all the way through, you'll have to go so fast that you don't go deep enough for anything except for a basic level or survey level of understanding, which we don't want a survey of electronics. The survey of electronics would be for non-engineering electronics students. We're for engineering electronics students, so we have to choose our topic. So that's going to be, I'm usually going to determine these for you, so I'll provide direction, but that's the reason why we do that. Lecture tips, remember, our goal is design, synthesis, and troubleshooting, not terms and definitions, not regurgitation of facts. Regurgitation and memorization is not engineering. Engineering is design, synthesis, and troubleshooting. Industry wants troubleshooting over and over again. They tell me they want troubleshooting. Most of all. Design and synthesis is more for real engineers, but we want to have some level of design and synthesis, not to the engineering level. But we certainly want to have the most advanced level of troubleshooting that we can have, especially in an A student. Lecture tips. PowerPoint has a drawing pin. It's cool. Presentation mode, hit Control P. So when you're in presentation mode, hit Control P and you will be able to draw. Some people don't know this. A lot of people don't know this. Also hit F1 for other things. You can hit, I think, E or B or something to blank or erase a screen. You can get a white screen by hitting white, W. So there's a lot of different tips you can do for PowerPoint to draw in class if you don't want to. If you have the screen down, you don't want to. You can't draw on the board because the screen's down, then you can just draw on your PowerPoint. For example, I guess I could do a slideshow right now, and if I hit, I think if I hit white, this W, the screen goes white. If I hit it again, W, then it comes back. I think if I hit erase, and if you hit F1, there's a bunch of tips on what you can do. Ink, pointer, media, different things. Okay? Lab tips. Create a circle pattern around your students during lab, giving each student as equal amount of time as possible. Don't spend too much time with one student. This happens all the time. And don't sit down and do the work for them. Please don't do that. Instead of solving their problem, get them to think about how they should approach the problem. What questions should they be asking? Just make sure that you just don't let one student trap you or stop you. Get into a pattern of stopping for 30 seconds at each station, then go to the next one. Just walk away from the student if they keep talking if you have to. But make sure you show equal equal amount of time. They're all paying for the course. They all deserve equal time. It doesn't depend on how loud a student is or how much a student thinks they need help. The students deserve equal amount of time. That's all I have to say. Lab tips, troubleshooting tips. Okay, so if the student has a problem, first thing they should learn is to do a continuity check, make sure their connections are good on a node. They need to know at the very basic level of nodes and meshes and things like that. And a node needs to be connected at every point. So if we got a node that has 3 elements, then test all 3 elements. And then they need to check the DC voltages with the DMN. They need to know how to do this on their own without you having to tell them. Try to wean them off of you having to tell them this every time. Maybe even print this out and give it to them. Check the package orientation. That's one of the #1 problems. Package orientation. They got the package in backwards. Have data sheets in front of them. A lot of times they don't put the data sheets in front of them, so they don't know what they're looking at. A lot of times they don't have schematics in front of them, so they don't know what they're looking at. Do they know the correct voltage? What should the correct voltage be? They have to calculate that. They need to be able to know how to calculate that. After all that, if it doesn't work, measure the current. Is there any current? Zero current? Lots of current? Medium current? Whatever. They need to know how to use the current meter. If AC, then signal tracing from start to the end. So they start at the signal and go all the way through. And once you lose your signal, then you know that you had a bad connection. Power elimination. That's pretty much the basics of that. Make sure they understand the breadboard, internal wiring. A lot of times they mess that up. They don't know how the breadboard is wired. So you have to train them on that. And they need to know how to use all their equipment, and they need to have good training on that. Lab tips, create your own labs. You don't have to, but you can. If you want to create your own labs, they're usually more fun and interesting, but you don't have to. Make sure students learn the following skills during lab time. simulation software, they have to learn Multisim, and OrCAD is required. It's required by ABET, which we want to move towards. It's also required by UNCC. They have to purchase Multisim. All the rest of them they can get for free. Download OrCAD free. Donna or Arnett at the bookstore has the Multisim. It's a pre-order at the beginning of the semester. Need to order it at the end of the first week. Need to get all of it. Make sure the students talk to them. Say you need to order Multisim. They need to know how to wire, build stuff, troubleshoot, continuity checks, calculations, test equipment. They need to know operation beyond the basic levels. They need to be at advanced level. This is a technician. This is not an engineer. They need to be taught. Engineers aren't taught this stuff, but technicians absolutely have to be taught how to use equipment. Not just to your basic level understanding, but I'm talking about get the manual out and go to the advanced level of understanding of all the equipment that they're using. And make sure you use industry recognized standard equipment, not out of date old equipment. Computer skills. Industry wants Microsoft skills. They want PowerPoint for presentations. They want Excel for data manipulation. And they want Microsoft Word skills. Make them write reports. Make them do presentations. And make them do data analysis. You have to do this. Please do this. Testing, automation with LabVIEW. You can automate all this equipment. Very useful in industry. I need to get more licenses, so we're going to have to work on building up our LabVIEW skills. Other software required for other programs. So all this software is for the DCAC classes, basic. But for the other classes, EagleCAD, fabrication, Quartus 2 is for the digital class, Verilog, VHDL is for the digital class, MP Lab is for the microprocessors, possibly Arduino, C++ is microprocessors. And that's all I can think of right now, but of course you have ladder logic for the PLCs, Allen Bradley, whatever software they're using, Siemens, whatever we decide to use on that end of it. And I would also prefer to have MATLAB. You need to get MATLAB software as well. And I think that's most of it. That's all I have for now, and I appreciate you watching this video, and I wish you well in your teaching this semester, and thanks a lot.